All right, good morning. Two lectures left, two quizzes left. You now know my game, right? I do this every year, and everybody's like, when's going to be the quiz? Well, the dominant strategy is to essentially do all 6 in the last 6 lectures, because then everybody comes to every lecture. But, I mix it up a little bit. So the 2 last quizzes, last 2 lectures, if you haven't figured out that today's going to be a quiz and you're at home, you deserve to lose 3% on your course grade. Organizational stuff, we'll deal with all of the organizational stuff next time. Final, how long, what, where, when, how many points. Oh my God, I'm so worried, I'm freaking out, Max. We'll do that next time. I want to talk about economics today. So what I've got left is one more market failure, which is a good one. And I've got to finish up externalities. So last time, what we did is we talked about externalities. Externalities are simply things where the total cost of your activity doesn't fully accrue to you, right? So whatever it is you're doing, you're either causing some damage to others or some benefits to others, but you are not getting those, right? So if you're keeping bees, there's the whole bees and the flowers thing, and then fruit magically arrives somehow. I did not do well in biology. But the basic notion is if you're a beekeeper, my neighbor Richard has bees. I grow lots of vegetables in my backyard, not this year, but last year I grew a lot of vegetables in my backyard, and his bees come over to my yard, and then vegetables and fruit appear. So there's a positive externality from his beekeeping that I get the benefit of in terms of pollination services. So what we will see is if you have positive externalities, the market left alone will produce fewer than the socially optimal amount of activities that produce positive externalities. If Richard had coal-fired power plants in his backyard and we're generating electricity instead, and lots of exhaust came wafting over onto my house, and I would start getting sick, then there's a negative externality. So the market left alone, when you have negative externalities, produces too much of activities that have negative externalities on them. So what we did last time is we showed that, right? So firms produce too much output on pollution. Frankly, it's a total... it's just not enough time to really explain how much economics you could do in this particular setting. You could take a whole class on environmental economics that essentially just deals with this and the public goods problem, which we're going to deal with later today. So the economics of externalities and the economics of public goods themselves are really interesting, and you can get a PhD in it. That's how complex it gets, because there's spatial dimensions to it, where the shape of the external cost curve matters, how much uncertainty there is around these costs matters. So it gets really interesting really quickly. But the basics, as we now have it, it's no longer called the Pigouvian tax, but it's called I'm going to abbreviate your name again, Zach tax, because it sounds zippier than a Zachariah tax. That sounds too long. But the basic amount, the basic thing that we advocate here is, since firms do not internalize the full cost of their production activities when there's a negative externality, what we do is we make the government take on the role of the Lorax. I speak for the trees, right? And what the government does is it makes the firm internalize the external cost in the form of a Pigouvian or Zach tax, right? Where the government charges the exact amount of the marginal external cost at the socially optimal amount of pollution. So the government essentially steps in and fixes that market failure, and firms themselves will produce the socially optimal amount of pollution and output. If you don't do that, there's deadweight loss, right? It's inefficient. Firms will produce too much pollution, and we're not at the socially optimal output level. So a couple of things about taxes. Economists don't like all taxes. We like some taxes, right? Most economists will say, well, income taxes they're just easy to collect in terms of government revenue. So if you're going to have to raise money to redistribute income and pay for goods and services that government produces, income taxes are a good way to do it because we record income really well. Everybody has it, and there's a whole system built up around income taxation. But income is a good thing, right? So what you're essentially doing is you are punishing people for working more by taxing them, and we can show that income taxation is actually distortionary, which is just fancy talk for it causes deadweight loss actually. So there are other ways to think about taxation. And there was a really nice column by Paul Krugman about a half decade or maybe a decade ago. I'm aging really fast. That basically said, why do we stick to taxing income as our main source of government revenue? Why don't we, instead of taxing income, shift to a society where we're just taxing externalities, right? So charge the full external cost of gasoline, for example. So when you burn gasoline, local pollutants come out. So NOx, particulates, all kinds of nasty stuff comes out of the tailpipe, plus CO2 emissions. So if we charge the full social cost of what a gallon of gas actually costs society, it's much closer to $10 than it is to $3, right? So the external costs from gasoline consumption are really high. A colleague of mine, Michael Anderson, and I, who's also the guy who wrote the Yelp Open Table paper, wrote a paper about the external cost of large vehicles, right? So have you lately been to a parking lot? Have you seen what the BMW X5 now looks like compared to the first one? I mean, cars are just getting bigger and bigger and heavier, right? The Honda Civic today is about 800 pounds heavier than it was a decade ago. So cars are just getting much, much heavier and much bigger. So if you're in your little old crappy Nissan Sentra 1993 vintage because you're an undergraduate student and you can't afford anything better, would you rather get hit by another 1993 Nissan Sentra, or would you rather get hit by a 2015 BMW X5? You don't want to get hit by the smaller car, right? Getting hit by a bigger car is a bad thing. There's more momentum, physics happen, and more people die. So what we essentially did is we looked at the universe of car accidents in 9 big states, and we police officers write down the VIN numbers of cars involved in accidents. So we got those VIN numbers and then figured out how heavy cars were, and figured out what happens to the probability of dying in a 2-car collision accident if the other vehicle is heavier than some counterfactual vehicle. Turns out your probability goes up of dying in a car crash. Conditional on being in a car crash goes up by almost 50% if the other vehicle is 1,000 pounds heavier. So there's a huge externality here when you step onto the parking lot and buy a big car, right? You privately pay for the safety benefit. So when you first started driving, Dad took you aside and said, son, daughter, I love you, and I would love to buy you a Porsche 911 convertible, dark blue, midnight blue maybe, brown leather seats. I think that's the killer combination there with nav and a good stereo. But because I love you, I won't, right? What I'm going to buy you is a Volvo 240 DL, 1989 year. They are indestructible. In fact, Arnold Schwarzenegger drove his tank over one, and it didn't destroy the car. So I'm just using my bad sense of humor here to tell you that when you step into a parking lot and you buy a big vehicle, you are paying for, out of pocket, the safety benefits of that vehicle. So if somebody else hits you, you're better off. Bless you. So if somebody else hits you, you are better off. But you are now in a bigger vehicle. How does that make Max feel in his very attractive Ford C-Max 2014? Not so good. It's a little car, right? So if you hit me in your big hunk of crap, if I may say so, I'm worse off. So you, by choosing a a larger vehicle impose an externality on everybody else. So in equilibrium, what will we see? We will see a fleet that's inefficiently heavy. Are we seeing a very heavy fleet? Have you been on the highway lately? It's not even, California is actually okay. Go to the Midwest. It's really scary. I used to rent a compact car. Now I don't rent a compact. I rent a midsize to make sure I'm safe. I'm joking. But the point here is externalities are everywhere, right? So once you start thinking about the world in these terms of what do people actually pay for when they buy something versus what's the full cost of their actions, it's not just pollution and trees dying, right? Anywhere you look, there are externalities. And this gets ramped up. Society is getting bigger in the sense there's lots of population growth in the US and India and China, for example. So people move to cities. So we're sitting on top of each other more and more and more. So your actions repeatedly affect more and more people simply because populations are becoming more dense. So this issue of externalities is one I really want to stress is an important one to understand and think about. Now, so taxes, the correct externalities, not income taxes, move us to an efficient, meaning welfare maximizing allocation as a society. And the nice thing is, if you collect that tax revenue from externalities, you could just take that revenue and lower the income tax rate, right? So why not tax bads and offset tax on goods? In fact, that's going to be my campaign slogan if I ever run for office. It's going to be tax bads, not goods, all right? So I'm not going to get elected with that slogan, but I'll have Bruce Springsteen as my VP. It'll be okay. So the notion here is you could use these good taxes that move us to a social optimum to actually offset some of the taxes we charge on things like income. Another nice thing about taxes is we can show in an environmental economics class that they actually provide significant incentives for technological innovation. If you're all of a sudden being charged for your pollution, you're going to start thinking about, well, could I use a different type of technology that would be cheaper than actually paying this tax all the time, right? So taxes actually incentivize innovation. But the problem here with taxes, and that's why regulators aren't so excited about these, is you're charging a tax on, a production activity, and we don't really know what firms' marginal cost curves are, so we don't really know what the slope of supply is. So what happens is you charge a tax, you don't really know how much you're going to get in emissions reductions exactly, right? You know they'll go down, but for a given tax amount, you don't know by how much. So regulators don't really like this. They like to get emissions reductions with certainties. The other thing why firms don't like this is all of a sudden firms pay taxes on all emissions, right? They don't just pay it on the amount that they reduce by, but they pay taxes on every unit produced. So their cost of production will go up. They don't like this, but frankly, the economists would say, duh, that's sort of the point, right? So it's disliked by firms, not necessarily liked by regulators either, but from an economic point of view, really one of the most efficient ways of reducing emissions. All right. Now, rock stars look different, but this is what rock stars in my field look like, okay? So this man here, don't laugh at Coase. You can't laugh at Coase. The man's a genius. I'm joking. Of course you can laugh at Ronald Coase. So Ronald Coase, University of Chicago, one of the brightest economists to ever have walked the face of the planet, got a Nobel Prize. This is what a Nobel Prize looks like. So when you get a Nobel Prize, you get one of these in real gold, and then you get a fake one for your desk, right? There's a really great podcast somewhere where a Nobel laureate tried to visit his mother in Wisconsin and took his gold Nobel coin through TSA, and it's a brick of gold. And they were like, what is this? He's like, it's a Nobel Prize. It's made out of gold. What's that? Why is it out of gold? So they thought he was lying to them. Why are you carrying a brick of gold around? He was just trying to show off his prize to mom. But the point here is, what Coase did was something really quite incredible. It's a really smart insight, and it's resulted in what we see today are these emissions trading schemes. So I'll explain to you what those are first, and then I'll tell you why this is a smart idea. So instead of charging a tax on every unit produced, what you could do is you could just simply issue a property right to pollution, right? So this is sometimes called a permit to pollute. Lots of environmentalists really hate this idea because granting a firm the rights to pollute seems just inherently wrong. But essentially what the regulator does is it says, okay, you want to produce a ton of CO2, you need to have a permit for that. If you don't have a permit for emitting a ton of CO2, and you emit it anyway, we will charge you massive fines, all right? So what you can do as a regulator then is you figure out how much CO2 you want to come out of your industry. You issue permits in exactly the number of tons of pollution you want to come out of the smokestacks of your industry, and then you give them to firms, right? So there's probably going to be fewer of these permits than firms would want to emit if you left them alone. So what firms do is they have a choice, right? They can either abate, meaning emit less, or they can start trading these permits. So this is an incredibly smart way of approaching emissions reductions because you don't have to figure out what the optimal tax amount is. You just issue the right number of permits and then let firms figure out whether they want to abate or trade these permits. So these permits are traded in financial markets and they have a value, right? So you as a firm then figure out, is it more expensive for me to reduce my emissions by 1 unit, which is what abatement means, or is it cheaper for me to just buy one of these permits? So firms make these decisions. The nice thing about this way of thinking about the world is that if it's really expensive for you to abate your emissions, meaning reduce your pollution, you just buy a permit. Versus if it's relatively cheap for you to abate emissions, you actually abate emissions. So what the system does is it actually achieves a set of emissions reductions at least cost. It's a very, very inexpensive way of meeting a given set of emissions reduction. This doesn't mean that reducing emissions is cheap, but if you set yourself a goal, right, let's say we want to decrease CO2 emissions in California by 20% by 2020, you might as well do it at least cost, right? So why do something at not least cost? This to an economist doesn't make any sense. So what is this really based on? So it's this notion of a property right. So what would happen if I walked up to you and I grabbed your Surface and walked home with it? He'd probably punch me, right? And would I blame him? No, right? You could probably punch me too. So the notion is, I'm slow, is what I'm saying here. Why can't I take your computer away from you? It's yours, right? So you bought it with your money, and it's yours. So you have the property right to that computer. I can't take it away from you. It's backed up by a legal system, so I can't just grab it, right? What about the atmosphere, right? If I want to pump a ton of CO2 in the atmosphere, is the Lorax going to come out of the woodworks and try and punch me? He can try. He's little. Yeah, I'm actually a big fan of that book. That's a really great book. I should read that to you guys, so in case we weren't read to as kids. But the point here is there's certain things where property rights aren't well defined, right? Nobody really owns, a cubic foot of the atmosphere. It belongs to all of us, right? So the notion here is for certain things, private goods, things you own, right? Property rights are well defined. Something is yours, and if there's a good legal system to back you up, and maybe some enforcement to back up that legal system, you can't just grab things from other people and make them yours, right? So a property right is an exclusive privilege to use an asset, and it underlies everything we do in this society, right? Property rights are well defined. You have a property right to this lecture. If some random person walked in off the street, I could ask them and I could say, are you paying tuition at this fine university? If not, I have the right to kick that person out of the lecture hall. You guys, by paying tuition and getting 4.4 GPAs in high school, and I don't know what else you did. The reading admission files is terrifying, makes me feel like a loser. But the point here is you have a property right to this lecture. It's well defined and it's enforceable, right? I have cops on Segways that can enforce this. But there are many, many places in this world where property rights to gadgets aren't well defined, right? That's a bigger issue. But even here, property rights to certain things aren't defined. So what Coase came up with is a theorem. You know you've made it when you've come up with a theorem named after yourself. So I've got the yoga theorem. Coase has the Coase theorem. So what Coase showed, and I'm going to show you this by an example, the actual paper itself is a tricky one to do, but what Coase showed is that the optimal levels of pollution and output result from bargaining between the polluter and its victims if property rights are clearly defined, right? So what he argued is if you define the property right over the atmosphere, and you either assign it to the polluter or you assign it to the people who are suffering from pollution, as long as one of these two sides of the market actually has an enforceable property right to that asset, which could be the atmosphere, could be a lake, could be a river, optimal levels through bargaining of pollution will arise, which seems like a crazy finding, right? All you have to do is you have to say the atmosphere is yours, all right? And then you let people suffering from pollution and people producing pollution just bargain in a market or over a table. So what you will see then is once a party has a property right over something, parties will bargain, right? So you see this all the time. If your surface is cooler than my surface, right, I could say, I really like that computer, let's bargain, right? If I gave you $5,000 for that thing, would you sell it to me? Right away, right? You'd probably wrap it up even for that amount of money. But the point here is we can negotiate over what type of payment I have to make to you in order for you to sell me your computer. The same thing happens with environmental quality, right? So polluters and people who suffer from the pollution, they can bargain over access to that particular resource. So I'm going to show you an example in a second where you have a polluter and a recreational company that use a lake. Depending on who owns rights to that lake, they can bargain over how much pollution goes into the lake in order to maximize overall societal welfare or individual welfare, which I'll show you will result in maximization of societal welfare. So it seems a little bit vague, and when I first heard this as an undergrad, I said that's crazy, right? There's some mathematical trick here that must work out because all you have to do is you have to tell somebody they own something and everything's resolved. Okay, well let's look at this for a second. This is your first payoff table, all right? A payoff table right here, it works pretty simple. I'll show you how these payoff tables work. They're a really neat way of looking at the world. So the setting I want you to think about is boats versus a chemical firm. Okay, so you think of a lake. This example is from Perloff because I really like it. Think of a lake, and Germans love to row, right? On Sunday you go out on the lake, you rent an old wooden rowboat, and you sit there, you take a case of beer, you row out onto the lake, you drink your case of beer, and then you take a nap and you row back. So rowing in Germany is big, and in order to have a nice rowing experience, what you want is a clean lake, right? So you don't want some stinky lake that has a bunch of pollution and dead fish in it and algae. You want a nice, clear lake. So if you had one too many beers, you can jump off the boat, go for a nice swim, hop back on the boat, and then take your nap. But there's also a chemical firm at this particular lake which produces, let's call it stinky pollution, all right? They produce stinky pollution measured in tons per day that they emit into this lake, right? So if they emit more pollution into the lake, it becomes stinkier and people want to row less and they'll just go to alternate lakes. So let's think about what happens here. So this payoff table on the y-axis here lists for the chemical firm how many units of pollution that chemical firm emits. And I'm making it really simple here. It's just 0, 1, or 2. You could make this continuous and really messy and graphical, but it's just easier this way. So no pollution, medium pollution, high pollution. On the horizontal axis here, I have the boat rental firm's number of boats rented per day. So they either rent 0 boats, 1 boat, or 2 boats, right? Because maybe they only bought 2 boats, right? Small scale operation. Now what are these crazy, diagonal lines here with the different colors? Let me tell you, right? So if there's 0 pollution in the lake, and the firm and the boat rental company rents 0 boats, the boat rental company gets $0 in profit, and so does the chemical company. So whatever it says in a cell, in one of these rectangular cells on this table here, the top right part, the dark blue one, tells me the payoff or profit to the boat rental firm. The bottom left part here tells me the payoff or profit of the chemical firm. Let's use another example. What if we have full-on pollution, 2 units of pollution, and 2 boats are rented? The company actually loses money, right? And the chemical company rakes in $15 worth of profits. So what we want to figure out is if these 2 firms are left alone, what would they produce? So sometimes, and this is the case here, you can actually figure this out. You can't always figure this out, but the way the payoffs are structured here, you can figure it out. So if you look at the chemical firm, if it produces 0 units, it makes $0 in profit if 0 boats are rented, $0 in profits if 1 boat is rented, $0 in profits if 2 boats are rented. If it ramps up its pollution, it makes $10 if 0 boats are rented, $10 if 1 boat is rented, $10 if 2 boats are rented. So irregardless of what the boat company does, the chemical firm is better off producing 1 unit than producing 0 units, because in all states of the world it makes $10 instead of $0. So if we go down one further, we really ramp up production. You see it's 15 for 0 boats, 15 for 1 boat, and 15 for 2 boats. So again, independent of what the boat company does, the chemical firm makes $15 in profits in all 3 states of the world, which is higher than the $10 here. So what's the chemical firm going to do? They're going to produce 2 units of pollution. Okay? This is a game here. It's not really a game. Let's not call it a game. But this is an example here where everybody has perfect information. You can make this infinitely complicated by who gains information when and how that affects action. But for now, let's assume that the boat company knows this. So the boat company then knows that it's optimal for the chemical firm to produce 2 units of pollution because producing 2 units of pollution dominates producing 1 or 0 units. So now what is the boat company going to do? It knows the chemical firm is going to produce 2 units. Right? So it knows it's in the bottom row of this table. So it just looks at its payoffs. -3 if it rents 2. 1 boat, it makes $2. 0 boats, it makes $0. So what's the boat company going to do? It's going to rent 1. Right? So the equilibrium here is going to be one where there are 2 units of pollution produced and 1 boat is being rented.